Alright, we're going to work on 2.4, which is box plots, sometimes called box and whisker plots, sometimes just called box whisker plots. But we're going to do a descriptive statistic that provides a graphical image of the data. The graphic shows how far the extreme values are from most of the data. Okay, and usually it's going to refer to, I don't want to say usually, always, we're going to be able to really see that middle 50%. Our box is going to be constructed off that middle 50%. In order to do this, we're going to need the minimum, the maximum, Q1, Q3, and Q2. Remember, Q2 is a alternative name for the median. When we have those numbers, those 5 numbers, this is referred to as the 5-number summary. We've done a lot of this already in the previous section, but now it's just organizing all of this stuff together to give us a descriptive. So the first thing to do you're going to find the 5-number summary. So you're going to find minimum, maximum, so that has to be in ascending order, because we're also going to find Q2, Q3, and Q1. We're going to draw a horizontal axis with a scale that includes the maximum and minimum data values. Now, it doesn't have to be horizontal. You'll see sometimes box and whiskers are vertical. There's a couple textbooks that I have that never draw a horizontal box and whisker, always vertical. I think if you were to look on your ACT results, they're always horizontal. Okay, in the section of those results that compare you to others that have taken the test. We're going to draw a box with vertical sides through Q1 and Q3. So basically making a rectangle, and the left-hand side of your rectangle is going to pass through Q1 and Q3, and there will also be a vertical line passing through Q2 that will be on the interior of that rectangle. Once you've got that rectangle, you're then going to draw a line from the Q1 position all the way to your minimum value, and then you'll draw a line from the Q3 all the way to your maximum value. If there are any outliers, you will identify your outliers with asterisks or just a dot or an X at their position. So here is an example. It says the number of meteorites found in the U.S. states, in 10 U.S. states is shown below. Construct a box plot for the data. So it first gave me all the data in just random raw data, no organization. First thing we have to do then is put them in ascending order. So putting in ascending order, all I did there, I hate organizing data like this by hand. So I just went quick to Excel, typed those in, asked to sort it, and then copied them back down. Quickly tells me what my minimum is, tells me what my maximum is, 296. And what we're going to find out, since this is an even number of data points, our median is going to be found between those two numbers right there. Okay, you got 4 numbers to the bottom of those, 4 numbers to the top. So the average, or the average of these two is 83.5. All right, so that puts my median right there. So when it puts my median right there, 78 is not my median, 89 is not my median. So those numbers there are the lower 50% of my data. And these are the upper 50% of my data. So let's find the midway point between those. So Q1 is going to be halfway in the blue, which would be 47. And Q3 is going to be halfway in the green, which is 164. Okay. Now, in regards to an outlier, we need to be able to determine what our IQR is. So remember, your IQR is Q3 minus Q1. So in this case, it's going to be 164 minus 47. That turns into be 117. And then possible outliers exist with, we'll call this I'll call it my lower fence first. So your lower fence of determinant outliers is found by taking Q1 minus 1.5 times your IQR. Well, for us, that's going to be Q1 was 47 minus then 1.5 times 117. Okay, I'll evaluate that in a moment. Then we're going to find what we call our upper fence. And basically lower fence, upper fence, they're boundaries for determining whether data points are like the rest. So if it's something below the lower fence, it's an outlier. If it's above the upper fence, it's an outlier. So the upper fence is created by taking Q3 plus 1.5 times your IQR, which a Q3 in this case was 164, minus 1.5 times 117. So I'm going to quickly determine what those are. So this one is 339.5. And then if we go 47 minus 1.5 times 117, negative 128.5. So because these numbers, so that number is my minimum. If I compare these, because there are no points that are obviously less than 30, so none of them are going to be less than negative 21 or negative 128.5. So I have no outliers below. Because my maximum is 296 and this upper fence is way beyond that, there are no outliers above. So now it's a matter of actually constructing our box plot. So I'm just going to come to the side. Actually, I'll do it down here below. It'll be easier. Just create a horizontal or vertical line. I'm going to do mine horizontal. Most of mine I ever make they're just going to be horizontal. Just what I prefer. So I'm going to, it says include your, make sure you create a scale that includes your minimum and maximum. I'm just going to go by 30s. I think that will work. So 30, 60, 90, 20. Makes sense because of all the different values that we have to plot. The 5-number summary that we have to plot here is to actually, when you're making your scale here, go ahead and identify what each one of these tick marks means. You don't want to put 30 and then a bunch of tick marks and then 300 and have to go, okay, well, what was this tick mark right here? When you have to apply these data points. So first thing we're going to do is identify our minimum. What I like to do is I come to my minimum and I just make, basically on my 5-number summary, I'm going to make a vertical line through all of the values of my 5-number summary. So 30, my max was at 296, so 296. And I like to also, because my scale, because 296 isn't showing up on my axes here, I'll actually write here max equals 296. Down here, min is equal to 30. I'm going to go find Q1 then, 47. So 45 would be halfway in between these two. So 47, not too far off. So Q1 is 47. Q2, 83.5. So there would be, what, 75? So 83.5, maybe about right here. So Q2, 83.5. And then Q3, 164. So, there'd be about 160, 170, about halfway in between there. So Q3, 164. All right, so what these vertical lines do is they serve as our edges of our rectangle. And then we go and take these horizontal lines. We try to make them as straight as possible. I know I've deviated a little bit from that, but your box here, that portion is going to go through Q1. That edge of your box is Q1. You're going to have your median in the middle. Now, it doesn't have to be directly in the middle, because remember, this tells me how my data is related to one another. So my median is closer to this edge of the data than it is to this edge of the data. My middle 50% is Q1 to Q3. That's my middle 50% of my data. and you can see that my middle 50% hugs closer to 30 than it does 296. Okay, if you think about your data points, okay, a lot of them are hovering kind of in that range, that smaller region between 138, 164, or 30 to 164, and then these two are not close to your middle 50. So it kind of gives you that structure of your data. Now, you see here I gave you some syntax for GeoGebra. We can type this in GeoGebra. Now I don't want you to use this solely. I would like you to get some practice at doing this by hand first. But what it allows you to do, let me see if I can change the size here. You're going to type in box plot. So when I type in box plot, it gives me the options here. It gives me what I have to type in. So the offset, all that is if I leave it at 0, which I'm going to do, it's going to show you it graphed on the x-axis. If I show it to 1, it'll graph it up at a y value of 1. Basically tells me how to offset it from the x-axis. My scale will mess with the y scale. It just essentially makes it the rectangle fatter. So I just usually leave those two things at 0 and 1. And then you saw it said list your data. Well, when you list your data, you have to put it in curly braces and type your data in. Okay, so when I type my data in, it doesn't have to be ordered. Okay, it will order it for me, and then I'm just going to hit enter. And it's just going to give me A equals 83.5. It identifies my box plot by what the median was. Okay, now looking at my x-axis here, it's not out to 83.5, so I'm going to get out here to that, and maybe we zoom out far enough. Let's see if I can zoom out to see. Okay, that's going from 30 going to by tens. I can make it a little bit thicker so we can see a little bit better. But you can see that resembles my what we did by hand. Okay, so I can't get it to 30s, but I can get to show the scale going by 20s, and that roughly mimics what we came up with by hand. Okay, you can click then. I think we should be able to. Maybe if we go to intersect. There should be a way. I'm not 100% sure. I don't use this a whole lot. That will identify what that value right there is of Q1, Q3, and so forth. The offset, all that does, if I double click this, let's say I want to offset by 1. Circular definition, yeah. Apply, there you go. And you see that it just puts now the center of that box through a height of 1. If I went offset of 2, it's going to go up to 2. Apply. You see it moves up. If I want to make the Y scale different, I don't know the purpose of this other than maybe if you're going to print this off and try to prove a point with a visual, but it doesn't change the data. It just changes the way it kind of looks, I guess. But that would be a box plot. Okay. I think it's a good idea to be able to use GeoGebra here to see, what is did I do my 5-number summary right? Get my interquartile range right, all that kind of stuff. Says note approximately the middle 50% of the data falls within the box. Okay, so you may also encounter box plots that contain outliers in which the whiskers do not extend to maximum and minimum values. So we'll see. I don't know if this example will have an outlier in it or not, but we can see. It says test scores for a college statistics class held during the day are those. Okay, and then one during the evening are those. It says find the smallest and largest values, the median, in the first and third quartiles for the day class. Find the smallest, largest values, the median, in the first and third quartiles for the night class. So A and B are saying find the 5-number summary for both classes. It says for each data set, what percentage of the data is between the smallest value in the first quartile, the first quartile and the median, third quartile largest. What percentage of the data is between the first quartile and the largest value. Okay. Create a box plot for set of data. Use one number line for both box plots. And it says which box plot has the widest spread in the middle 50. So basically, what this is structuring us to do here, make 2 box plots, put them on the same number line, and then compare them. Okay, so I'm going to take a moment. I'm going to type these into Excel so it puts them in order for us, and then I'll resume. All right, so just a reminder here, all I've done is I've typed these 2 lists in, A and B. So I'm going to highlight A, and I'm going to go down, we'll right click. Actually, I'm going to highlight these this way. I'm going to go down, right click, and go to sort smallest to largest. Says Microsoft Excel found data next to your selection. Since you have not selected this data, it will not be sorted. So that's fine. What it's telling me is that it's seeing 99 and 98, and I don't want these coupled to where it sorts these based off of these. So that's fine. So continue with the current selection and sort. And then I want to do the same thing with these. Right click, sort smallest to largest. Continue with current selection, sort, and we're good to go. The sort tool allows us to really tie 2 cells or adjoining cells together to sort, like a name of a person. Like if I gave each of you, I would put your names down and then put your age and days down, and then I want to sort them, I would highlight both and say sort column A off of column B's age, okay, or whatever defining characteristic. Okay, this is, I just wanted this sorted just by smallest to largest. Okay, so what's nice here is that you see a situation where we're actually going to have data in which when we compare these 2 courses, they're going to be obviously we're going to compare the 2 classes, but they have, one class has more people in it than the other, which is fine. But it's a benefit of what box and whisker plots allow us to do. All right, so as we do this, I'm just going to construct our 5-number summary under the day class. I always like to put what my IQR is in these lower and upper fences as well. So even though it's a 5-number summary, I'm going to do these 8 things. Just quickly running through this. So we've got, I believe it's 20 pieces of data here. So we'll scratch these 2 off, scratch those 2 off. Just trying to find the median here. And it gives me 72 and 77. So I just want to double check, make sure I didn't check off too many above here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 above. 1, 2, 3, 4, 5, 6, 7, 8, 9 above. So we're going to look at the average of that. Okay. So that'll be Q2. So 72 plus 77 all over 2. So it's at 149. 149 divided by 2. Is that 74 and a half. We'll find Q1 and Q3. My minimum obviously is 32. And my maximum is 99. Now Q1, remember it's now halfway in between those 2. So 32 to 72. So cross that one off, cross that one off, that one, that one. And now we're going to be looking at the average of those 2. So we've got 1, 2, 3, 4 below that, 1, 2, 3, 4 above that one. Average of 56 and 56 is 56. And now we'll look at these. '81 plus '84, so it's at 165. So we're looking at 86. So 165, 83. So 82.5. IQR then is going to be 82.5 minus 56. So 82.5 minus 56. It's 26.5. So then my lower fence, remember that's Q1 minus 1.5 times my IQR of 26.5. So let's see what that is. We got 56 minus 1.5 times 26.5. Gives me a 16.25. So there are no scores less than that. So there's no outliers on the lower side of my data. Upper fence will be then 82.5 plus 1.5 times 26.5. So 82.5 plus 1.5 times 26.5. 122.25. So again, no data values above that. So in this case, at least in my day class, I'm not going to have any outliers. Alright, so now we're going to do the same thing, but we're going to do it for the night class. So the minimum is 25.5. The maximum is a 98. Alright, so here we've got 22 pieces of data. So I'm going to cancel those two, cancel these two, those two. There are other strategies, especially if your data list is very long, of doing this, but I like this one. So that gives me 81 and 81. Averages of 81 and 81 is obviously 81. So right there, I mean, we're going to compare these in a little bit, but you can see right there that night class had a median score that was better than the day class. Q1 then, so we're going to be finding the halfway point between those. So cross that one off, cross that one off. Getting too messy here. $78. So that's Q1. You can kind of start to see some patterns here. So if I've got, what, 1, 2, 3, 4, 5 data points here, 1, 2, 3, 4, 5 data points there. So I'm going to have 1, 2, 3, 4, 5 data points above, 1, 2, 3, 4, 5 below. So that tells me right there that 89 is Q3 for this one. So there's different structures that allow you to find that median of the upper or lower sets of data quicker. IQR then, so 89 minus 78. 89 minus 78. In this case, we see that our IQR is a lot smaller than the last one. than during the day. So it gives me just 11. And if I want to go my lower fence, so lower fence Q1, so 78 minus 1.5 times 11. My upper fence will be 98, or sorry, not 98, 89 Q3 plus 1.5 times 11. Evaluating that stuff, then we get 78 minus 1.5 times 11, so 61.5. And then here we get 89 plus 1.5 times 11, 105.5. So there's no values that are bigger than 105.5, but if I look at my list over here, there's quite a few that are below 61.5, I believe. See if I can select this a little bit better. So 61, so less than 61.15. These two numbers would be outliers. They're less than 61.15. So we'll identify those when we graph this. So outlier 25.5 and 45. All right, so now we're going to construct our two box and whiskers on top of one another. So I'm going to create my horizontal line here, and we'll draw it to scale. So my lowest data point was 25.5, so I'm just going to make 25 be my smallest, and we'll just jump by fives. So 30. Alright, so just constructing my axes from 25 to 100, intervals of 5. One thing, try to keep your intervals as consistent as possible. So I'm going to do the day one first, so minimum of 32. So maybe about right there. Q1 was at 56. Maybe about right there. Q3 is 82.5, which is right there. And then my maximum was at 99. So right there. So minimum 32, Q1 56. Oh, Q2 74.5. I think I was missing one. 74.5. About right there. So create my box here. Remember, that's Q1, Q2, Q3. This is your min, which we said was 32. This is our max, which we said was 99. Q1 was 56. Q2 74.5. And Q3 82.5. And we'll then create our whiskers. One whisker. And then there's our second. Alright, so that was the day. So I'll put that up here. right, now I'm just going to do the 90. Now you can do it on top. You can do it wherever you want. I'm going to do it on the bottom here. So my minimum was at 25.5. So right there, it's going to allow me to tell me, well, in that class, my lowest score of everybody showed up in this night class. Q1 was 78. So maybe about right there. Q2 is 81. Q3 is up here at 89. And then my max again was 98, so a little bit less. Create my box. Oh, I made an error. I'll address it in a minute. There's my box. Okay. Remember, we had outliers. So 25.5, even though that is my minimum, it's an outlier. 45 is also an outlier. So the other value, the next value that would have been involved would have been the 65. So that's my minimum that I'm actually going to graph on here. So 65 right there. And then this 25 and what was it, 25.5 and 45. I want to identify those as outliers. And now we can see our data. We can compare them. Okay, we can see obviously our middle 50% here is spread out much more than our middle 50% was here. Remember this. So this value here is an outlier. That value right there was 65. Q1 was at 78. All right, so our Q1 is above the median even of the day class. Our Q2 was 81, and Q3 was 89. So our data here is more clustered, okay, with more of our people in this second class. Kind of their scores are grouped tighter together in that middle 50% than what these were, okay? The middle 50% here goes from 55 to 82.5, so you can do that spread, okay? And obviously that spread would be the IQR, which we said was 26.5. Here our spread was only 11, so you can kind of make that comparison that these are more compact, okay? But that's the purpose of being able to use these box and whiskers. It allows you to quickly kind of judge between two sets of data, okay? And then you can start making inferences. You can start making arguments. Okay, well, why is the day class different than the night class? Okay, well, if it's the same instructor, maybe it's that instructor has taught this class now a second time in that day, and maybe they're a little bit better the second time. Okay, night students. Okay, night students are maybe your older students. Okay, they've maybe got jobs, they've got families, they've got kids, and even though that those variables could maybe mean why they could maybe do less or perform less, there are also variables that could increase performance. If I know that I've got to do well in this class because I need it for my credentialing to stay employed because I need to feed my kids, maybe they have a little bit more intrinsic desire to be successful, and that's why these scores are better than what these scores are. So those are all things, once you have the data, you can start to analyze. Hopefully this makes sense. We can do the same thing down here with this. This is called a dot plot. Okay, kind of looks like a histogram almost, but essentially all we're doing here is the same idea. If I look at scores, I have one score of 5, one score of 7, a one score of 10, one score of 15, a score of 19, two scores of 21, two scores of 22, five scores of 23, four scores of 24, and one score of 25. So if you're going to do this, I'll let you guys do this one on your own. That's how you would write your data out that way, and then go through and find your 5-number summary, find your IQR, identify your lower and upper fences so you can kick out certain values for your outliers. And this just talks about how if a data value is an outlier, the whisker plot does not extend, or the whisker does not extend to it, and by default changes the endpoints of the whisker, and they no longer identify the max and min. They identify then essentially the next value up. Okay. So hopefully this is making sense. I do know that you guys have seen some exposure to this when you were younger, but it's been a while, so hopefully this is a good refresher. I just took a quick moment to put these into GeoGebra. Now, I don't know the coding. Like I said, I don't use this a whole lot, but it appears as though GeoGebra is not identifying the outliers like we would have, but you can still see this would have been the night class, this was the day class. You can still see how that data is so much clustered so much tighter than this middle 50 here. Again, like I said, I'm not sure ours, the way we cut it off was like right here with the whisker, because the 25 and there's 25 and a half, and I believe the 45, those scores were outside the lower fence. Email me if you have any questions. My plan is to move on tomorrow to measures of central data, measures of central tendency, that kind of stuff. So we're start doing some more computational stuff, deal with some formulas and stuff like that tomorrow.